Hey everyone, in today's video, we're going to see about handling missing data in large data sets. I took an example from Netflix. There were a time they used to handle a lot of missing data because none of the users were showing interest giving rating for the movies they are watching. And still we used to ignore giving a like or dislike for such thing when we watched, or even if we like watching movies, we just ignore giving likes or have it as a most watched one. But back then, how they actually handle those things are very interesting. So I just the core problem of Netflix, where the data is very sparse and depends on the category and the users. So they will take only the users who have given the rating for the movies, list of movies they have watched, and they just spread across a particular way in a matrix based on the list of users and the list of movies. So any number of movies they can take and they just going to sort that with a list of users. So the empty spaces which will be question mark because the particular user didn't give ratings for other movies. But some of the users would have given ratings for such movies. So they just take all that and filled every rows and columns based on that. And if it is missing, there will be a question mark and that need to be rated so that they can have an average for each movies, and they will recommend based on the similar users. So the challenge is we have like n number of missing data, only 43 percentage have filled, the remaining is empty. What we need to do is we need to find few things which Netflix have been following it. So they have used a few techniques that actually worked for them in the beginning. So we'll see that in this video. So let's take this sparse matrix. So what you see in blue is filled, I mean the rated movies, and the empties that you're seeing. So the missing data is more compared to the actual input, I mean the present data. So we have like 98 percentage of missing data, 98.7 percentage. So first thing is, let's start by taking average. So that is the ultimate uh, method everybody will come across. But here the problem is when we take a matrix, I mean the filled and non-filled matrix, if we take an average of calculating all the, I mean summing it up with filled values and taking a total, and the average is 3.9. When we give 3.9 for the empty rows, when we take a rating for it, it is going to be a failed model because the movies which supposed to have like great ratings will have less, and it will greatly impact towards the uh, audience who prefer to watch such movies. So the imputed with global mean is 3.9 which we have given, and it is greatly affecting. When we take an RMSC with global mean on Netflix, it is 1.13 which is very poor. So we are moving into matrix factorization. This is one little advanced method compared to the mean. What we are going to do here is taking user and a movie in terms of k value. So k is something that we can assign, and it is basically 20 to 200 depends on the matrix size. We can assign values for every iteration or every row and column iteration that we can just give. With this, we can actually achieve for empty rows as very least value, and for the actual value we do have the value like 0.9, and for the empty for Alice I've given no ratings. So we are considering this particular category as 0.1 for Alice. We're just grouping based on the categories for every users so that Alice have given and have interest in action, and she don't have interest in romance. But Carol have interest in romance, but not in action. So we just take this particular user preference data, comparing with the movie feature. So what you have is action and romance. You're not giving the user directly, but we took a category of an user alone. So this information we have and this information we have because we categorized it and grouped it. And we are going to multiply these two and take a value out of it, where we are getting for a single row and column matrix, we are getting 0.27, which scaled to 1 to 5, which is low rating because the scale is 1 to 5 and we have like 0.27. So we cannot just consider this as well. Mean imputation which we got is 3.9, which is actually wrong again. So we are going like little advanced method which covers like most of the targeted MT values right now. So soft impute algorithm. Here what it does is like the steps that we're going to consider, which is going to start with Z's value by assigning all zeros in the beginning. Later, we're just going to replace it with a matrix. I mean, the value which we observed with the matrix multiplication. So here, the ultimate value for every iteration, we are going to have a lambda value. In terms of a lambda, so what you seeing here is a simple iteration that we're going to conduct. So first iteration we just happen to have like 1.8 and each category and movies have been different value it is obtaining. And the next is so for every iteration we have like proper values that have been changing, and at fifth iteration we have like predicted values of each. So this converged missing values which happened because of the soft impute, where we are giving that with a lambda value. So this is the a matrix that we are including in the dimensions in terms of lambda, and we are including an identical matrix in it. So with that we can have, and also we are going with this soft threshold, where the threshold actually does is if it is like too low than the threshold value, we are ignoring that, considering it's a noise. And if it is beyond the threshold value, we are about to have it as a noise again, and we are removing it. And we just keep only the values in between, which we can consider that as an actual value, and uh, that is going to impact in big time with the data that we are having. So ALS is another one where which included with an identical matrix in here, as I told already. So with all these steps we are able to achieve the good RMSE, and the missing values have been placed. So this is a soft impute where you're going to have a matrix of for the threshold value, and the lambda have been used in order to cut off the noises, and you have an identical matrix. So with all that, user and movie have been grouped and multiplied, and we are just going to assign a value for each missing data in every iteration. So that is how it does. So we can see the RMSE here only with soft impute, and after adding the ALS and YSS, we have like 0.89 of RMSE, which is like very less compared to global mean. And that is how Netflix have been achieved handling the missing data in the beginning. But now it have a lot of how to say, we have a lot of views and most clicked, and there are like multiple categories and durations of watching the movie, and how many times the same category have been watched from a user. So these information are they are taking, and it is more about less user interface, but getting those information and providing a good service for them. So this is an extension that they have made in recent times, and they are using deep learning embeddings and contextual features for all those uh, things to achieve the good service for the users. So this is how the imbalanced data can be handled in such big applications or tools or softwares. So that's all I have for today. I hope this video finds you well. So see you all next video. Thanks for watching. Bye.